Voyager 1 is a space probe launched in 1977 as part of NASA's Voyager program to explore the outer solar system, a cold, vast, and mysterious region far from the warmth of the Sun. Within just 3 years, Voyager 1 completed flybys of the giant planets and their moons. By the early 1980s, it was on a one-way path out of the solar system and into interstellar space, beginning the final stage of its mission. In the nearly 40 years it has been traveling since, humanity has managed to study all 8 planets of the solar system along with the belts and regions that lie between them. But the solar system is enormous, stretching billions of kilometers, and the space between star systems is even larger. Even though Voyager 1 travels at around 17 kilometers per second, covering nearly 1.5 million kilometers every day, it will not approach another star for about 40,000 years, long after it has gone silent. During this lonely journey into the galaxy, the probe will eventually pass beyond the icy outskirts of the solar system and reach the boundary of interstellar space. One day, far in the future, Voyager 1 will become the first human-made object to arrive at the very outer edge of the Sun's influence. But what actually lies at the outer edge of the solar system? It is not a planet, and it is not a belt. It is a gigantic, diffuse cloud of trillions of icy objects, forming a kind of shell around the solar system and possibly extending more than a light-year into space. This is the Oort Cloud. The Oort Cloud is a hypothetical bubble of icy debris that surrounds the entire solar system. These objects range from tiny particles to mountain-sized fragments made mostly of water, methane, and other frozen materials. Unlike the orbits of planets and belts in the inner solar system, which follow the Sun's flat orbital plane, the Oort Cloud is a spherical shell of material. It is thought to begin thousands of times farther from the Sun than Earth and stretch trillions of kilometers into space. Out here, the Sun appears no brighter than a normal star among billions in the Milky Way. Because the objects in the Oort Cloud are only weakly held by the Sun's gravity, they do not orbit neatly or follow a single direction. They drift slowly, influenced by one another, by the pull of the galaxy, and by passing stars. Small disturbances can easily send these icy fragments toward the inner solar system, where they appear to us as long-period comets. No object has ever been observed directly in the Oort Cloud, but it remains the strongest explanation for the distant comets that occasionally fall toward the Sun. These bodies, along with others beyond Neptune, are known as trans-Neptunian objects. Their distances from the Sun increase so dramatically that astronomers measure them in astronomical units, the distance between Earth and the Sun, instead of kilometers. At 5 astronomical units lies the snow line, where it becomes cold enough for water and other substances to remain frozen. Neptune orbits at about 30 astronomical units, and beyond it lies the Kuiper Belt, a thick, donut-shaped region filled with billions of icy remnants from the early solar system. It contains comets, dwarf planets like Pluto and Makemake, and even Neptune's moon Triton, which may have originally formed there before being captured. The Kuiper Belt is incredibly remote, but its size is tiny compared to the Oort Cloud. Light from the Sun takes about 4.5 hours to reach Neptune, and another 3 hours to cross the Kuiper Belt. After that, it travels another 10 hours to reach the heliopause, where the Sun's solar wind collides with the radiation of interstellar space. Even then, we are nowhere near the Oort Cloud. Its inner edge is at least 10 light days away from the Sun. Its outer edge may lie more than a light year away. Scientists believe the Oort Cloud formed from leftover material during the solar system's creation. In the early days, countless rocky chunks called planetesimals filled the system. As the young planets grew, especially massive Jupiter, their gravity flung many planetesimals outward. Some escaped the solar system entirely. Others were slowed by the gravity of the Milky Way and settled into orbits far beyond the planets, forming the distant cloud. It is also possible that the Oort Cloud contains material from other stars. The Sun likely formed in a cluster of hundreds of stars, all surrounded by their own disks of debris. As these stars drifted apart, they may have exchanged material, sending planetesimals from one system to another. If true, many objects in the Oort Cloud could be extrasolar, born around stars that no longer exist. Even though the Oort Cloud has never been directly observed, its existence is supported by long-period comets. These comets take more than 200 years to orbit the Sun and often appear only once in recorded history. Some have orbital periods so long that the last time they passed through the solar system, humans had not yet evolved. Astronomers Ernst Oppik and Jan Oort developed the theory in the early 20th century. They realized that comets must come from a reservoir far beyond the Kuiper Belt. Oort also noted that long-period comets arrive from all directions, suggesting a spherical source rather than a flat disk. Over time, researchers expanded the idea, discovering that the Oort cloud likely has two parts: the outer spherical shell and the inner Oort cloud, also called the Hills cloud. The Hills cloud may contain more comets than anywhere else in the solar system, supplying new ones to the outer Oort cloud over time. This helps explain how the reservoir has remained full for billions of years. One object, the planetoid Sedna, discovered in 2003, may be part of the inner Oort cloud. Sedna follows an extremely elongated orbit that takes more than 11,000 years to complete, carrying it hundreds of astronomical units from the Sun. Its strange orbit suggests it might belong to this distant region, although this has not been confirmed. The outer Oort cloud is extremely diffuse. Even though it may contain 2 trillion objects larger than a kilometer, they are spread across such a vast distance that each is separated by millions of kilometers. The combined mass of the outer cloud may equal only a few Earth masses, making it very difficult to detect. Only when an object is disturbed and sent inward does it become visible as a comet. We have observed many long-period comets that likely came from the Oort cloud. Examples include Comet Siding Spring, which passed close to Mars in 2014, Comet Hale-Bopp, one of the brightest comets of the 20th century, and Comet Lovejoy, which survived a close pass through the Sun's corona in 2011. These comets reveal clues about their icy origins, carrying signatures of extreme cold and ancient formation. In the distant future, 5 human-made spacecraft will drift into the Oort cloud: Voyager 1, Voyager 2, Pioneer 10, Pioneer 11, and New Horizons. They will reach its inner edge in hundreds of years and take thousands more to cross it, long after their systems have died. Many mission concepts have proposed studying the Oort cloud directly, but none have been approved. The distances are simply too great to send a probe and receive meaningful data within a human lifetime. Future telescope technology might one day detect Oort cloud objects from Earth by observing how they block starlight as they pass in front of distant stars. Most stars likely have their own Oort clouds, formed during their creation and shaped by gravitational interactions with the galaxy. These distant shells are invisible to us, but the comets we detect around other stars hint at their existence. Space is unimaginably vast. No matter how powerful our telescopes become, the scale of the universe remains far beyond our reach. Every star you see in the night sky holds its own planets, its own history, and its own Oort cloud, hidden in the darkness. Our solar system is just one of countless others, each with mysteries we may never fully understand.